Hey, I had someone ask a question about this problem from discussion 8, and it has to do with the right hand rule. So it's really hard to explain without sort of showing a picture. So we're trying to do it here. And so what's happening is you've got this triangle piece loop with current in it, and we're trying to figure out which way this rotates in this external magnetic field. So it's an external magnetic field, which means there's a magnetic field caused by something we don't know what from the outside. And so the first way to do this, and just real quick, so this is discussion 8. I talk about this in lecture 22, pre-recorded lecture 22, so you can go there and check right at the beginning, sort of this concept. But the first way is using the flat right hand rule, and we look at these as being different segments of current inside a magnetic field and interpret it that way. So here, the current is up, so the velocity is up. My fingers point that way, and so there'd be a force into the page right there. Now this guy, well, this guy, we'll start with that, that's parallel to the B field, so no force there. This guy, my thumb goes again with the velocity, my fingers go this way, and it's out towards you guys. And so if we look here, there's a force in here and a force out here. And so if we sort of just take something to sort of pretend this is the triangle, where my thumb is, it'll go in, where my fingers are, it'll go out, so it'll rotate this way. And so if you look, the way we looked at or described this in the discussion sheet is like you're staring down the y-axis, okay? And so this thing, it goes in on this side and up over here. And so hopefully, when you look at this, you'll see what that means is that it's going clockwise in the y direction, which is what it's supposed to do. All right, so that's the first way to think about it. The second way is the way that maybe I like to think about it if I'm trying to do it sort of quicker. And this is the idea. This is a loop of wire which will have its own magnetic field, and that magnetic field wants to line up with the one that's out there. And so now we use curly hand rule 2 to figure out the direction of the magnetic field. So my fingers go around this way. My thumb points into the page, which is what we're sort of looking for here. And so that means my magnetic field of the loop points into the page. And I want that to line up with the magnetic field, which, you know, will end up being the same rotation. So you can think about it either way. And the way you can kind of do this, which maybe might work out semi-decently. So here's my loop. And again, you're staring down the y-axis. Here's my loop, and the magnetic field points the way this magic marker does. And so it wants to line itself with that external magnetic field, which should be the same rotation, which again should be counterclockwise as you're staring down that y-axis. And so I would definitely suggest, you know, doing both ways to make sure that they work. And again, if you're stuck on this, you can go back to lecture 22. Thank you.